All right, guys. So this is problem number three. It's a frames and machine problem. So the problem says determine the horizontal and vertical component of force at pin B and C. Okay. So we know that we can break down this whole structure into segment BC and segment AC, okay? Because there's a hinge right there. So we can break it down. So first, let's consider AC. Okay. Let me draw a frame diagram for AC first. So like I said, you can assume any direction of where those reaction forces going to at the beginning. So let's say CY is going downward. CY is going to the right. And then AY going downward as well. And then AX to the right. Okay. And then as we can see right here, here's a 50-pound force that's 50 pounds force at this pulley right here. Okay. Which meaning that if there's a 50-pound force going to the right, then we know that by pulley, there will be another 50-pound force that's going downward to counterbalance it out. And then if there's a 50-pound force going downward, it means that this thing must have a 50-pound force going upward so that they can cancel out. So this whole thing stays in equilibrium. Okay, that makes sense. Okay, so it means that if you consider the Fibonacci diagram, I have to write this off, Fibonacci diagram of AC. If we did a Fibonacci diagram of AC right here, meaning that we must have this 50-pound force going upward. And then we know that the Y is 6B, the X or the entire thing will be different. So as you can see, this 50-pound force is exerted on this rope right here. And this rope is not about the center where left will be 4 feet and the right will be 4 feet. Okay, it's actually 0.5 feet to the left. So which means that this distance right here would be 3.5 feet. The other one would be 4.5 feet. So when they sum out together, it'll be 55 feet. Okay. All right. So for this kind of problem, since there's 4 unknowns, which we can do at this point, most we can do is just take a moment so that we can at least cancel out 2 of the unknowns. Okay, so let's do the moment. So let's do summation of the moment about point A. You can do it either about point A or point B, it doesn't matter. You get the same answer. So I'll do it in point A. So point A, I have the CY going downward. That's in the counterclockwise direction, so negative CY. The perpendicular distance will be 3.5 plus 4.5, so I got 8. And then I have this CX going counterclockwise to A. So plus CX, the distance, perpendicular distance will be 60. And then I have this 50-pound force. It's going to A like this, which is counterclockwise. So plus 50, perpendicular distance, 3.5 feet equals 0. Okay. So 2 unknowns in this equation, so we can't really do anything. Let's see if we can do anything with this measure of force in the x and y direction. So in the x direction, ax and cx cancel out, so they both equal to 0. Force in the y direction. In the y direction have negative ay minus cy plus 50. Well, nothing useful that we can find. So what we can do at this point is that consider the Fibonacci diagram of BC. Okay, so Fibonacci diagram of BC. BC, we know that since we assume CX and CY as this kind of direction, then it means that at BC, they must be the opposite. So CY must go upward in this case, and CY must go to the right. Okay, and then however you want to assume for BY. So I'm going to assume BY is going upward, BS is going to the left. Okay, and then at this point right here, I have this 50-pound force. And then different points going downward as well. And then there's a distance of, I believe, 25 feet. Okay. So for this kind of problem, I mean, for this free body diagram, same thing for unknowns. I mean, not for unknowns. We at least we know that Cx is equal to 0. So what we can do at this point is that we can take a moment and take a moment about where, take a moment about point B, because B has the most unknowns. Because at point C, we determine that Cx is going to be equal to 0. Okay, so Cx, I mean, at point C, there's only one unknown, which is Cy, but there's two unknowns at point B, which is Bx and By. So we always want to take a moment about the point with the most unknown. So let's take a moment about point B. So I have this, I'm missing that. There's 1.5 G right here. So I have this 50-pound force right here. That's going clockwise to B, it's negative, and the perpendicular distance will be this 1.5 feet plus 0.5 feet. So it'll be 2 minus, oh, my bad, 1 second. So this right here will be 4 feet and 4 feet. But we're concerning about this rope right here. So it'll be 3.5 feet this way, 4.5. Okay, so I have this 50-pound force going like this to B, also clockwise, so minus 50 multiplied by 3.5. Okay, don't worry about the Cx, we have the Cy, which is going like that to B counterclockwise, so plus Cy multiplied by A equal to 0. So the only one unknowns, which is Cy, so we can basically solve for Cy. So Cy gets to be 34.38 pound. Okay, since we know that what Cy is, we can basically plug that in back into a summation of the moments about A. So we know that Cy is equal to 34.38, and then you can basically solve for this equation in terms of Cx. And you're gonna get Cx is equal to 16.67 pound. Okay, and then back to free body diagram BC. We can do the summation of force in the x direction to find out what Bx is. So summation of force in the x direction, negative Bx. I have my Cx. Oh, my bad. I made a mistake right here. So Ax will not be equal to Cx. It will be equal to 0. That's my mistake right there. So just ignore the summation force in the x direction. That's my mistake right there, guys. Okay, so force in the x direction. So Cx is not going to be equal to 0. So I have Bx to the left and then Cx to the right. Okay, and I have this 50-pound force to the right as well, plus 50 equal to 0. Okay, so I know that Cx is equal to 16.67. Solve for Bx, so I got Bx equal to 66.67. And then summation force in the y direction to find out what By is. The y direction, I have this 50-pound force going downward, plus the By, plus the Cy. Now that Cy is 34.38. basically solve for Vy, so I got Vy will be equal to 15.60. Okay, so that's all for problem number 3, and I apologize for making a mistake at point CX. Okay, all right, so I'll see you guys in problem number 4. So the previous 3 problem is all the free response problem that is going to be part of the exam, which is moment of inertia, friction, and frames and machines. Okay, and then the next 5 problems are all going to be the most important, the multiple choice. Okay, thank you guys for watching.